Hi, everyone, and welcome to the Wastewater Process Emissions webcast series. We are happy to partner with various organizations to present 4 webcasts in this series. Today is the first, titled Fundamentals of Wastewater Process Greenhouse Gas Emissions. I'm Michelle Suazo and wanted to run through a few housekeeping items before handing it off to our research program manager, Dr. Harry Zhang. Just so you know, you can submit questions through the question box at any time. We will plan to do a Q&A at the end of the presentation, so all questions will be handled then. Slides and the recording of the webcast will be available at our website there. You will also receive a follow-up email with a link to the video recording and the slides as well. Right now, you can download the slides to access the PDF of the presentation, as well as several links to different resources under event resources on the bottom left of your screen. A certificate of completion will be automatically generated after the webcasts, but if you have any questions regarding that, please contact me at my email as you see here on the screen. Please stay tuned until the end of the webcast. We have a quick survey for you to fill out, just so we can kind of manage how we're doing and make improvements where we can. We have a great lineup of speakers today. You can see their bios under the bio tab on your screen now. Now I'd like to hand it off to Harry Zhang to give you a brief overview of the webcast and introduce our speakers. So Harry, take it away.
Thank you, Michelle. So I'm Harry Zhang from the Water Research Foundation. So here's the agenda of today's webinar. So I'm going to spend a few minutes talk about the Research Foundation climate mitigation research portfolio. And I'm going to hand it over to David Ponder from US Water Alliance, give the overview of this process emission webinar series. And then John Willis from Brown Caldwell will cover greenhouse gas accounting standards, protocols, and methods. Amanda Lake from JCOP will continue on talk about fundamentals of wastewater process greenhouse gas emissions. And at the end, I think David will moderate us the session for the discussion and Q&A for us. So I want to, using 3 slides, give you sort of quick overview of the Research Foundation, climate mitigation, and also greenhouse gas emission research. The Water Research Foundation has divided our research into 5 research themes as shown on this slide. Climate change research has been further divided into climate adaptation and climate mitigation. For climate adaptation and then risk assessment, as you can see from this bottom arrow sign, there are cross-cutting issues for all the 5 research themes. Specifically for relating to today's, the focus of today's webinar is climate change mitigation, addressing greenhouse gases. This is a dedicated subtopic, as you see on the slide. So the purpose of this slide is trying to using some of the real product example, describe mini research roadmap from Research Foundation on the climate mitigation and greenhouse gas research portfolio. The total, just quickly, the total value of this example here is more than $1.2 million. So through the research partners, national organizations, and also the research team, we try to tackle some of the issues, knowledge gap identified by the IPCC 2022 report. So I just want to give you a quick snapshot. So the first 2 One Water project, they cover the drinking water and wastewater together. The first one is focus on greenhouse gas emission inventory from life cycle perspective. The second one, they cover the greenhouse gas emission library for both drinking water and wastewater, along with decentralized system. So the next 2 drill down into sewer methane and the nitrous oxide emission from wastewater sector. The last one, try to conduct some of the more rigorous comparison among different greenhouse gas measurement methodology here. Yeah. So this is my last slide for the introduction. So if you wonder, hey, do you have any resource for me right now? The answer is yes. So Research Foundation have been doing climate change research for more than 15 years now. So here, so we have a dedicated climate change topic hub on our website. In summary, we have more than 80 project climate change study across wastewater, stormwater, drinking water, and then reuse recycled water. And then those projects divided into climate adaptation, mitigation, and greenhouse gases, and also climate risk assessment. With that, let me pass to David.
Thank you, Harry, for that overview of the efforts of the Water Research Foundation. And thank you, Michelle, not just for starting us off today, but for everything you've done behind the scenes to make this possible. My name is David Ponder. I am the Director of Climate Action at the U.S. Water Alliance. I'm also the Chair of the Water Environment Federation Greenhouse Gas Focus Group. I'm so pleased to have the opportunity to speak with everyone on the call today. What I'm going to do is provide a brief introduction to the Process Emissions webinar series. First of all, I want to acknowledge and thank the organizations that have made this series possible. The series is organized by the U.S. Water Alliance and the Canadian Water Network. I want to give special thanks to my colleague, Mikkel Benfield at the Alliance, and Jessica Akande from the Canadian Water Network for their efforts to make today possible. We're also, of course, grateful for our gracious hosts at the Water Research Foundation for providing the platform to host the series. And as Harry noted, all of the important research they are funding. I also want to thank other contributors, the Danish Water Technology Alliance and the International Water Association for their contributions to support this webinar series. And finally, I want to acknowledge and thank the staff at the Water Environment Federation and the volunteer members of the WEF GHG focus group who provided their time and expertise to help plan and arrange the content for today and subsequent series. So special shout out and thanks to Victoria Weitkamp and Miley Lonabatora at WEF, Emma Shen at Jacobs, Chung Lee and Shannon Kavanaugh at Brown and Caldwell, Jose Porro at Cobalt Water, and last but not least, our featured speakers for today, John Willis at Brown and Caldwell and Amanda Lake from Jacobs. As all of you on this call know well, water utilities are at the forefront of the climate crisis. Those impacts are accelerating and will worsen if we do not collectively work to accelerate our efforts and actions and investments to reduce greenhouse gas emissions, both in the water sector and society as a whole. We can and must root out every opportunity to reduce emissions. That's why in 2022, the U.S. Water Alliance, and along with more than 35 water sector leaders, issued the call to action that you see on your screen today to achieve net zero in our sector by 2050 in a way that benefits people and the planet. I want to give you some context for why addressing emissions from the water sector and wastewater emissions in particular are important. The water sector overall, all freshwater resources, including water utilities, collectively account for about 10% of global emissions. Wastewater infrastructure, drinking water abstraction, wastewater treatment, drinking water conveyance, in particular, is also a non-trivial contributor to global emissions. And our current best estimates suggest that they account for at least 1.6% of total global greenhouse gas emissions. So while that may not sound like a big number, it is on the same order of magnitude of other high-profile sectors like global shipping and aviation. And moreover, while these best estimates demonstrate the magnitude of our contribution, it's important to note, and I think Amanda is going to talk about a little bit, they're very highly likely an underrepresentation of our actual contribution to emissions. These estimates don't include things like biosolids management, the energy that we use to power our facilities. They are underestimates. They don't include sewer methane emissions. So it's important that we have a fundamental understanding of what emission sources exist at our facilities and what the steps are that we can do to address those. And that's why we've set up this webinar series. Our goal is to deepen the sector's understanding of GHGs from the treatment process, what the types and sources of those emissions are, what the mechanisms and conditions in a facility that give rise to those emissions. We want to inform you about sort of the state of the art in terms of quantification, measurement, and monitoring emissions. And we'll also spend time talking about how we can reduce emissions. So today, we're just going to start with some fundamentals, but we want to build on those fundamentals in these subsequent series. We have one coming up in September, October, and December, each talking about various aspects in sources and gases that are unique to the wastewater treatment process. Our goals for today, just to give you, like I said, an overview of the sources in wastewater treatment, a quick snapshot on pathways and conditions. Again, we'll dive deeper into those in the subsequent webinars. So if you haven't had a chance yet to register for those subsequent webinars, please do so. And then we'll also spend time today talking about quantification and measurement and the information that we can get from using default methods for quantifying emissions and how that compares to sort of the emerging state of the art in terms of direct measurement. So I hope that you enjoy the content for today. I'm going to now pass the mic to my friend John Willis.
Thanks, David. So I'm going to be giving a bit of a rundown on greenhouse gas protocols in North America and other methods, and then talk about how a number of us in the wastewater and water industry are trying to advance and sort of take ownership of some of the protocols and methods that are being used in these protocols themselves. So generally, I'm going to go over the protocols and methods and then talk a little bit about the benefits and shortcomings, and then talk about how the wastewater industry could own those, and then talk about some other research that's going on outside of the WRF research that we're talking about in this presentation. So you may have seen this diagram before. What we're looking at is any number of emissions can be emitted from wastewater plants, and we're really generally talking about methane and nitrous oxide are the two big ones. Compared to carbon dioxide, the default assumption today is that the carbon dioxide that your plant breathes, that's biogenic carbon dioxide, and that you don't need to include it in your carbon footprint or your greenhouse gas accounting. But there may be future research that tells us exactly how much fossil carbon's coming in versus the biogenic carbon, and that split may happen at some point. But when we look at each of these emission sources, how do you go about measuring it? And what protocols do is give you a cookbook to basically estimate what your emissions are using a protocol-based cookbook. So the first thing that I'd like to go over here is just what's the governance? What is the coverage of different protocols? So IPCC, that everybody's heard of, is the international go-by for countries to report their greenhouse gas inventories. If we go inside of that, ICLEI has the U.S. Community Protocol, and what that does is it allows you to estimate how much emissions are being emitted by a community. And they do things, and those emissions include the general populace. So that's of interest there. The other two that I'm going to mention here, the other three in green, are different protocols that are either targeting, in the first case, the greenhouse gas protocol is generally for private entities, and then the climate registry's general reporting protocol and the local government operations protocol are for government entities. So there's a good chance that you're looking at doing your own inventories using one of these two that's shown here, whether it's the general reporting protocol or the local government operations protocol. Now, neither of these includes the emissions for the public around you. They're just good assumptions on the water and wastewater side for what you can estimate. The other thing that you may have seen, and this is in a number of cases, we see that the city or county government are doing the greenhouse gas inventories. And they might be estimating your water and wastewater emissions. And when we see these, a lot of times they are using the ICLEI US Community Protocol. But what you'll see when you get there is that that emission source, when they're covering all the emissions in a community, tends to potentially dramatically underreport what the water and wastewater sector is doing for wastewater emissions. If you wanted more detail and better estimates, then you'd probably be looking at the two in green in the bottom right. So the way that you do use the protocols, and let me just say first, the best thing the protocols do is provide consistency. Everybody is using the same numbers and the same methods and the same approaches. And generally, if you know what your activity level is, then the protocol will provide you with an emissions factor. And then the global warming potential tells you if you release a kilogram of nitrous oxide, that's worth about 265 kilograms of carbon dioxide. And if you release a kilogram of methane, that's worth about 29 kilograms of carbon dioxide. So when you're looking at these, they do a good job of making this pretty cookbook. The other thing they'll do is there are different levels that you're looking at. A bunch of them are very simple. And if the community knows how many people are in the community, there are population-based methods that have nothing to do with what's going on at the wastewater plant. And then higher tiers do use the data at the wastewater plant. Say in the case of nitrous oxide, how much nitrogen did I remove across the wastewater plant? And water resource recovery facilities. But the point is, if you have your operational data, that's considered a more accurate method. And yet it's still an estimate because the emissions factor is a good number to use, but not necessarily representative of what's happening at your site. So the things that the protocols don't do is they do a less than fantastic job about completeness. There are a bunch of sources of methane and nitrous oxide at wastewater plants and water resource recovery facilities that we don't know are within our fence line today. And the site-specific accuracy, they're using averages. And in something like nitrous oxide, your emissions per pound of nitrogen removed could be one number, or they could be 50 times that number. So that the accuracy on something that's pretty significant is when you use an average number, it doesn't necessarily get to your local site-specific conditions. So we talked about the lack of completeness and specific accuracy. What happens in these, almost all of the other protocols there assume that IPCC knows what they're doing better than the protocols themselves, so that all of these protocols are built on IPCC. So a lot of the factors are the same and they don't get changed. I think we're helping in some cases get some of the protocols in the wastewater and water space ahead of IPCC, but we're really just starting to change that. Now, the other thing that's in here is that the numbers in IPCC are averages for developed countries. So if you're using an average for a country, it's probably not going to match what your site-specific is doing. And so here's the question. Is it reasonable to assume that average emissions for the entire country are good for individual water resource recovery facilities? And then the next piece here, and if they're not, what should we do about it? So I'm here to tell you we're not starting from ground zero. So I'm going to go back over some of the things that we ought to do better as a wastewater industry. First of all, we ought to figure out how to measure accurately direct emissions. And direct emissions are the actual molecules coming off your wastewater plant. But if you measure in one place on your aeration basin, is that representative of the entire aeration basin? It may not be. So how to measure is an important thing. Can you measure once, go out there one day, and then apply it to the other 365 days? There's a bunch of questions here that we need to dig into. So once we figure out how to measure, we need to measure a lot more so that we can compare what the operational schemes are that either create more or less greenhouse gas emissions. And then we need to identify all the sources. As a, for instance, you can think that your aeration basin is an aerobic process, but I'd be surprised if anybody's WRRF does not emit methane from their wastewater, from their activated sludge process. So taking a look at that, where are the emissions? Do we know they're there? We think they're there. And can you measure them and go from there? So we do want to drive consensus. We do want to have as many people that are interested as possible weighing in and saying, yeah, that's good. You're taking care of what I'd like to see you do. So back to these emissions, there are a bunch of different things that we can look at. And taking a look at Harry's list of projects. What I'm going to do is a little deeper dive here on Harry's projects. And I'm going to start off with industry-wide guidance. This is a project that's being done by the U.S. Water Alliance. The project will result in an Excel-based tool, as well as a guidance report that tells you what the limitations and challenges are with using some of those, and what you should assume for defaults and the sources of those default emission sources. The idea is this project should allow more water resource recovery facilities to start reporting and estimating their greenhouse gas emissions by protocol-based emissions factors. So another project that's going on right now is sewer methane methods for everybody. I'm actually leading this effort. We have a number of utilities. There are 6 different utilities around the world that are going to do full-scale testing to figure out how much methane a gravity sewer produces. And then we're going to figure out what the best methodology is to estimate that and apply that to between 40 and 50 sewer sheds. And the idea is that we want to develop a simple methodology, like how many inch miles of pipe do you have? And what's your average temperature that somebody could estimate their methane from? Right now, that's not available. Now, there is an opportunity here, and my contact information is at the bottom of this slide, but we can still add members, not for the full-scale testing, but if you're interested in having your sewer methane estimate done, you'll get one equation per sewer shed, but the buy-in price is $20,000 per utility, and we'll do all your plants for $20,000. The next project here is on nitrous oxide. This project is being led by Jacobs. Amanda and Emma are 2 of the ones that are driving this. The idea here is to take a look at, they have over 40 water resource recovery facilities, and they're trying to figure out what are the consistent correlations that drive increased nitrous oxide or decreased nitrous oxide, also while looking for more nitrous oxide emissions around the plant. It's not just the aeration basins. All right, the other one, and this is a project that Princeton is leading along with Brown and Caldwell. We're creating a repository, and it's actually not us. It's the Climate Registry is going to be developing and housing this library. And the idea is if anybody's measured Scope 1 direct emissions, you can get online and upload them to the folder that has the greenhouse gas emissions. We're asking to add operational emissions, temperatures, what was your synthesis? What did you think it meant? And where do we go from there? We'd like the experimental plan so we know if we're talking about apples and oranges or whether they're all apples. Anyway, The other piece of this project is to convene an international greenhouse gas expert panel that we'd like to keep. There are currently over 40 people on it. And we'd like to keep it in place so that when we get to different topics, we get the experts on the phone, get their input, and we can reach a consensus faster by working together. So again, contact me if you have collected Scope 1 greenhouse gas data at your wastewater plant, or if you'd like to be on the expert panel. Either one of those, just shoot me an email and we'll add you. The last one here is a project that is not yet on the street. It's going to be a request for proposal that's coming out probably in the next month or two. But what it's asking for is using multiple methods to analyze water and wastewater plants and figure out which methods are good for which kinds of production. You know, is it better if you have a foul air fan and a covered tank to measure the methane coming off of that? It is. But if you don't have a covered tank, do you use a drone? Do you drive a car downwind? We don't know. So this RFP is going to be out later, and I hope you're ready to look at it. Other projects that are going on, there are a number of utilities who are either measuring their own emissions or they're putting out requests for proposals to develop greenhouse gas inventories. And some of those requests for proposals do want site-specific data to be measured and to have site-specific data to be put into the accounting. There's also a large project funded by NSERC, which is a Canadian grant that's being led by Toronto Metropolitan University. And then finally, and I think we're all pretty excited about that, this DOE is getting interested. And this is the IEDO, or the Decarbonization Office. And Mark Philbrick was leading this. We had a seminar in January. The idea is we don't really know how to measure these emissions. So DOE is looking to contribute to improve our ability to measure and know what's good, bad, or otherwise. So with that, I think I am finished, and I will hand it off to Amanda.
Thanks very much, John. Really great to be here. So I'm Amanda Lake. I have been leading a lot of the work on greenhouse gas emissions, particularly process emissions here I'm based in Edinburgh in Scotland, but I really had the pleasure of being able to work across our global organisation and indeed collaborate with many of us on the panel and many of those on the call too. So great to be here. I would really like to give a bit of an overview and signpost to a few nice references. And so I'm going to start with that because there's been some really nice, there's a very nice book, Quantification and Modelling of Greenhouse Gas Emissions, which was published by Iowa 2 years ago now. There's a QR code for it in your slide deck. And that really gives a fantastic, very technical, detailed overview. What we bring with this series, I think, is some of the practical utility experience as well. So that is a fantastic book. And the other one is a white paper. There's a working group, which actually anyone is welcome to join, around greenhouse gas emissions. And we recently published a white paper just to try to articulate a little more some of these, what we call scope 1, 2, and 3 emissions from water resource recovery facilities or from a utility. And John touched on this a little bit, but this white paper gives a really nice overview of what those different scopes of emissions are. And I would really recommend having a quick read of it. Today, really, we're focusing on this scope 1 emissions. That's a direct emissions of nitrous oxide and methane, and we'll get more into that soon. And you'll hear more about it in the detailed the second and third webinars coming up as well. So, but I guess firstly, just with a question, and certainly in different geographies, there's been different level of momentum on this topic. But I guess if we think about some of the reasons why we might want to improve our understanding of greenhouse gas emissions from water resource recovery facilities, there's the obvious one that David mentioned, where we are experiencing incredible global temperature change. It's not abating, and we really do need to act. I'm sure we all have loved ones that we really do care about their future. So that's a really good reason to start with. It's also a safety issue, particularly if we think about methane and leaking gases. As John pointed out, our greenhouse gas accounts are likely wrong and likely underestimated. And right now we're using these higher tier emission factors which aren't really representative when we think about how nitrous oxide and methane are formed and managed, and we'll talk more about that in this series. Something that we've learned certainly in Europe, I think, and in the UK sector where I'm based, is that we really need funding and money to move forward to try to tackle this challenge. So daylighting the challenge of process emissions by starting to measure and really improve our understanding is really the way to elevate the issue and try to get funding. And we certainly, if we're thinking about mitigating those emissions to try to meet our climate targets, whether that's a city or a country or indeed our international obligations, we need that quantitative data to really set baselines and to meet reduction targets and indeed to account for taxes which are coming in some parts of the world. And of course, if my background is as a process engineer, and if I'm trying to inform lower risk greenhouse gas technology choices for the next 20, 30, 40 years that our plant lifetimes, we really need this information to be making resilient low risk technology choices and to be able to really bring the best information to the work that we are doing in the water sector. So a bit of an overview of the scope 1 process emissions. Here we've got the three main gases. As John mentioned, carbon dioxide primarily is considered biogenic. And we don't, some utilities are thinking about accounting for it, but our main focus here is nitrous oxide and methane, which are both really powerful greenhouse gases with large global warming potentials. And in the case of methane, actually it only lasts around 10 or 12 years in the atmosphere, and its short-term global warming potential is even greater than that 28 figure you see here. But when we think about where these emissions come from, obviously under anaerobic conditions in our sewer systems, in our sludge lines, and indeed in our anaerobic and perhaps other parts of our secondary treatment process, we have methane emissions. We also have them from other places as well, but I guess as we start to understand them, a good place to start is where we know the majority of them are emitted. And that allows us to try to prioritize efforts as we're all in a learning curve. When we think about nitrous oxide, we're thinking about our aerobic and anoxic tanks in secondary treatment, and also in particular in side stream treatment where we're transforming nitrogen. And I guess that's just one more thing to note is obviously the methane is formed from the organic matter that we deposit in our sewer systems. The nitrogen is coming from the proteins in the food that we eat, whether that's cows or chickpeas. The nitrogen in the proteins of the food ends up in our sewer system, and a percentage of that gets transformed into nitrous oxide. So that's the source of our N2O. When we think about the production pathways for N2O and methane, these are complicated and we will get into them more. I think the key message is we know enough to measure and act on these emissions, but we typically simplify these biological production pathways. Here's the nitrous oxide ones, and we talk about anoxic and aerobic production pathways, and here we have three, number 1, 2, and 3, and they're performed by different organisms through different transformations of that nitrogen cycle. And then importantly, in the purple here, we have a nitrous oxide sink, which is really relevant because we can reduce our nitrous oxide in our biological processes potentially. So those are the simplified pathways, and we can start to think about the conditions that might give rise to these pathways, resulting in some of that nitrogen passing to nitrous oxide. So things like dissolved oxygen concentrations, ammonia loading and regime, accumulation of intermediates like hydroxylamine, nitric oxide, nitrite, things like pH, temperature, and also solids retention of the system. And we can also think about in the anoxic phase, of course, we know biological systems are complex and have both, aerobic and anoxic often going on at different levels. But in terms of this anoxic pathway here, where this is performed by a heterotroph in a kind of simplified model, and things like dissolved oxygen concentration, carbon availability and the type of carbon, also accumulation of intermediates, and things like pH, temperature, and solids retention time also can impact on the N2O emissions. But in reality, and the book is has some good explanation here, it's more complex than this, and there's plenty of things we still don't know. There's great research ongoing. It's all about electrons, but I guess a key message is that we do know enough to be able to act, and there's lots more to learn. When it comes to methane, I like to think it's a little more understood, and here we can think about intentional and unintentional methane, for example, in sewers, or intentionally produced in biogas systems. I won't dwell on that more, but we can certainly cover it in the methane webinar. But a key point is that these emissions of methane and nitrous oxide, and courtesy of Durham Region and Anglian Water here, we see that they are a significant part of our footprints, and they really do matter for our climate goals. So if we look at the proportion of emissions they make up, here it's almost 80% for Durham Region and 23% for Anglian Water, which is a UK utility. But if we think about the decarbonisation of our electricity, as that goes down, our greenhouse gas, as it decarbonises, our greenhouse gas emission contribution from these process emissions, which is the section in purple here, really increases. And so by 2030, which is the final donut here, it's a very large majority of Anglian Water's emissions. And the key point here is that they're underestimated as well. Just briefly, when we look across life cycle carbon, we still see that these greenhouse gas emissions of nitrous oxide and methane dominate, even when we think about life cycle assessment. And here we've got the very small blue capital carbon component of in this case, looking at different BNR options, and a 40-year asset life cycle, asset lifespan. And so added to that, we currently underestimate these emissions. And when the IPCC released the recent 2019 refinement, which some countries are using and some utilities are using, in this case, when Anglian Water started looking at the impact of using it, it increased their N2O emissions by 400%. And here on the right-hand side, we've got another UK utility, Severn Trent, and as they started measuring their emissions, they also realised that their N2O emissions were likely substantially underestimated by their accounting, emission factor-based accounting, which wasn't based on any actual measurement data. And actually it meant that their trajectory to net zero fundamentally changed, and that's something that's had a big impact in the sector here. So we're underestimating the emissions. But I mean, the really good news is that to improve our estimates and actually start to measure and mitigate, we have technology and it doesn't cost the earth. So there are different ways of doing this. We can think about site level measurement versus process unit level measurement. And here I've just got some different ways of doing that. We can think about continuous and campaign-based measurement, and we'll certainly cover this in more detail in the coming webinars. Because a key thing with nitrous oxide emissions is that they vary. So year on year they vary seasonally, and they vary spatially. So and they vary from facility to facility. So, and of course, to actually know that we're reducing them, we also do need to be measuring them. Here's some just examples of a plug flow aerated lane in a nitrifying activated sludge plant, and we can see that the summer and the winter emissions are very different. Here on the right-hand side, we have a facility in Denmark, and the point here is that year on year, the emissions are very different as well. They vary both by process type. So whether it's an oxidation ditch or a conventional activated sludge plant or an EPBR plant, but they also, as importantly, if not perhaps more importantly, vary by the operational conditions. So here on the right-hand side, we have a side stream process, very high emitting, very high production, and we see much higher N2O concentrations during periods where there's high ammonia loading, perhaps insufficient oxygen, low DO levels, versus periods where there's a lower ammonia loading from the liquors, there's sufficient dissolved oxygen and a much lower nitrous oxide, and that's a very dynamic system. Methane emissions, likewise, are highly variable and dynamic. The leaks indeed are invisible unless we use optical gas imaging, and there's a video on the left which doesn't work, I'm sorry, but we can really, have some very substantial leaks. And on the right, this is some drone survey work that we've done at a facility in the UK, and we can see that these emissions can be very transient. So, short-term surveys like drones perhaps offer us a chance to prioritise where we might like to act next. But certainly the continuous measurement is going to give us more insights. And so really also that measurement supports capital planning and operations, like which technology should we choose? Which should be our next focused monitoring and mitigation campaigns. So on the left here, we've got some different RNG upgrading technologies and other elements of the sludge line and different emissions from a European study. On the right-hand side, I mentioned the drone survey, and we've done that for a number of facilities for both methane and nitrous oxide. But it's really given us something to think about where to go next for our continuous measurement program, because we obviously don't have endless time and money. Just to wind up, just wanted to say a little bit about mitigation, because we really, we can mitigate today. In terms of nitrous oxide and methane, there can be, both energy but also financial benefits of doing so. And so just as a bit of a joke for a low nitrous oxide lifestyle, like there's things that we know that we can do today. So we can think about starting to measure things like having sufficient carbon for our nitrogen, good process control, cleaning and calibrating instruments. Can we balance those loads or supernatant returns? And are we seasonally optimizing our plant to really try to keep our bugs happy? The situations to avoid, and I mentioned some of these already, these aren't categoric, and every site that we start measuring, we are likely to learn something new, and it may be different from the previous site, and even one lane may be different from the next lane. So we have to inform ourselves and then try to make the best decisions we've got with the resources that we have. We also need to think carefully about things like intensification and carbon redirection, because we have very little data on these technologies, and depending on our grid electricity and the carbon footprint of our energy, we really need to be thinking, if we're trying to make holistic decisions, we really need that measurement data to be able to bring that into the equation, and a lot of the time we do lack that. So here's a bit of a hierarchy for nitrous oxide, things that are being implemented to mitigate. We'll go more into this in the deep dive on N2O, but I just wanted to make the point that it is absolutely possible. Here's some examples from Switzerland and the Netherlands, where we've got on the left-hand side there, we've got 3 different ways that N2O is being mitigated at scale. There is some regulation that's helping support this, which is fantastic in Switzerland. We've got advanced process control, we've got regenerative thermal oxidation, obviously, big energy consideration there. And then we've got changing out side stream treatment, because those side stream treatments can be super, super high emitting. On the right-hand side here, we've got an example just fresh off the press from the Netherlands, where there's a nice bit of work that's ongoing. This is early data implementing advanced process control, and here the analysis is still happening, but we see a period where the advanced process control was off, and we see that the blue and the green are N2O concentrations in anoxic and aeration zones, and we see those really drop down where the APC is turned back on again, and in this case it could be to do with the oxygen recycled in the nitrates and optimizing those recycles. Methane, we can also reduce today. I don't want to go into detail here because I know we'll cover that in the methane webinar, but really would encourage us to think about what we can do as, as designers, as supply chain manufacturers, as municipalities, and as regulators. And if we look globally, there's some really nice examples of progress. I would signpost again to some of the Iowa webinars we've had on this as well, and we're going to hear much more in this series. So just to finish up, I just thought myth busting is also quite a nice thing to do, because sometimes there's a lot of, can be some misinformation out there, but importantly, there's some really good news about process emissions. So, fixing leaks can be cost effective today. We do know enough to be able to start measuring, and we actually can mitigate too. We know enough to mitigate. Modeling, there's various different modeling approaches. They all offer promise. Can we quantitatively use models and predict N2O emissions amazingly to support mitigation? Not yet, but there's lots of exciting work ongoing. And a reason for that is we don't fully understand the production pathways and mechanisms, but again, lots of work ongoing. Side stream processes can be like super emitters of N2O, that is definitely true. If we leak too much of our biogas, then it may turn out that we're not actually green at all, and unless we're measuring it, we're really not going to know that. Some technologies I've sort of talked about as inherently low N2O emissions technologies like MMBR. I think the evidence is there's a lot of potential there, but we should definitely read the detail there and really be starting to do those measurement campaigns and sharing and collaborating. We do lack full-scale data for many processes, and that really is great to see all the WRF projects ongoing, because we really will be building that up both in North America but also globally as well, and that's really what we need to drive action. But the good news is that reducing methane and nitrous oxide will give us better process outcomes, and there's good evidence for this. So just to finish up, thank you very much for being here today. And just a shout out to my colleagues at Jacobs who are all doing fun work on this together. And I'll look forward to the Q&A with everyone just now. Thank you.
Thank you for that presentation, John and Amanda. These presentations have spurred quite a set of questions from our audience. I think we're going to start with some of the more higher level ones and then maybe work down towards some of the detailed ones. We have a question in here about where can we get updates on research efforts noted on the project list. Harry, I think you've got an answer for us on that.
Sure, I'll give a quick answer. So the first thing really I would encourage the people to sign up the free e-newsletter from the Research Foundation website, because we issue RFPs and also some of the project update and then some of the project newly contract project. Second, I think I mentioned the Research Foundation Climate Change Topic Hub. So you can go there and then download this 18-page project list, and then each project has a 4-digit number. And then using that 4-digit number, you can sort of search the Research Foundation website, grab the report if they are finished. One thing I think those reports are publicly available in a way like a public plus access. You need to have a free Research Foundation account to access to it. So that's it. Yeah. So.
All right, thank you so much, Harry. And I think folks had to either be a WER subscriber or sign up for that access account to register for the webinar. So you should all be able to get access to those resources Harry talked about. There are a number of questions in here asking about where can I get a copy of this report or that resource that was mentioned in the webinar. What I can promise to you all is that we, as those that help organize this, will make sure we compile the hyperlinks for all of those resources and make them available post-webinar in the webinar website that Michelle was referring to. I believe that will come, a link for that will come to you in the follow-up email from today. There are a couple of questions in here about updates on a couple of projects. We're 5220 and what we think the timeline on that is. Harry, do you have an answer for that? Or John?
I mean, I do. Yeah. So that's the sewer methane project. And I think Zanetta asked that question.
Yep.
So we're doing the summer testing is going to be done at all the facilities sometime between August and mid-September. And that'll be the first effort where we've really been focusing on trying to figure out what those experimental plans look like. But I think as soon as that testing is done, we'll have something in the mid-fall, Zanetta. And the idea there is that we need to get some of the other pieces like your sewer methane, your sewer hydraulic model output files. We need to start working on that now as well, because that's going to be something that we do the analysis with for Louisville.
Great, thank you for that, John. There are a couple of questions in here that I think are just sort of good questions about the language that we used and referred to in this. So, John, you use the basic greenhouse gas emissions formula. There was a question in here about what that activity data variable represents.
Yeah, so activity data, and I mentioned like population-based emissions factors. The emissions factors have units, and it would be kilograms of methane or kilograms of nitrous oxide per population equivalent. So that's an operational. It's the function that the equation needs in order to estimate it. You could, on the other hand, have how many pounds of nitrogen did you discharge to the environment, and if you have that activity data, then you apply how much nitrous oxide evolves per pound of nitrogen discharged. So the activity data is the part of the story that tells you how much emissions you have. It's a lot of times it's a scale factor. Sometimes it may also be a temperature factor. And hopefully that helps a little bit. Yep.
Yeah. Thank you for that.
The IPCC guidelines, I was just going to say the IPCC guidelines, like that 2019 refinement, it's not scary at all. And actually it gives you a really good definition of what those activity coefficients are and how you can use your national data. And then you can kind of cross-reference that with what your national or your local entities are doing. So don't be scared to read the refinement, and we can share the link for that as well.
Excellent. Amanda, this question came up during your presentation. What are we talking about when we say fugitive greenhouse gases?
Yeah, I mean, we tried to address this in the Iowa book, actually. I mean, we are talking about gases that are leaking from our water resource recovery facilities. Now, some people, and the IPCC doesn't define this. I mean, these are emissions that are produced when we treat wastewater, like what we're talking about is the methane and the nitrous oxide, sometimes the carbon dioxide that are produced when we treat wastewater. So some of them might be leaking from pipe fittings and from vents on top of tanks. For example, in the case of methane, in the case of nitrous oxide, the N2O is being emitted in the aeration zone. Even it may be produced in our non-aerated zones, but it is typically, by and large, being stripped from our aeration zones. So they're fugitive in that they're being emitted. They're certainly, in the case of methane, it may be we're intentionally producing methane, but there's some leaks and some slip that we aren't intending. In the case of N2O, it's a byproduct of our biological nitrogen treatment. But I think really when we say fugitive emissions, we are talking about those Scope 1 process emissions of nitrous oxide and methane, both leaking from cracks and valves, but also being emitted from our open, secondary digesters, our sludge tanks, and our biological reactors. I hope that helps. Unless you guys want to disagree with me, but it isn't. I don't think it's actually officially defined, but I take it to mean all of what we're talking about today.
Well, and I just want to, let me just add to that, because you find out what you think you know and what the protocols have. So the protocols say assume 1% of your produced digester gas is emitted as fugitive methane. And we've seen plants that were the vacuum air release valves that prevent the digester from collapsing could be emitting 50 to 500 standard cubic feet per minute of digester gas. So that's a lot more than that 1% number. The other one that we found was recently with floating cover digesters at a specific plant. We found that they were losing a third of the methane out of the annular space of the floating cover digesters. We believe that's a function of mixing patterns and other things, but sometimes you don't know you got a problem until you measure it. And you got to be looking in order to find it. Yep.
So
yeah, and there's some good work that's been done in Denmark. We could share as well on that, maybe in the links. Yeah, they found their, on their wastewater facilities, they've emitted around 7.5% of their biogas was being emitted on average as leaks, which is quite a large percentage when you're trying to produce it for valorization.
Yeah, so this sounds ripe for our follow-on webinar that specifically is going to dive into fugitive methane emissions from wastewater treatment facilities. So make sure you're signed up and tuned in for that one. I want to keep us moving through our questions, so there are a lot of good ones in here. There are a couple of questions in here about global warming potentials and the difference between 100-year global warming potentials and 25-year global warming potentials, and sort of what is a reasonable global warming potential assumption to use?
I think the default is, if you're doing your inventory, to use 100-year global warming potential. But the thing that's come on the screen more recently is that, hey, we're behind on mitigating greenhouse gas emissions. So if we're going to prevent something from causing rising temperatures, methane might be the best one, because the methane is not in the atmosphere anymore 20 years later. So that if you want to make it cooler in the next 20 years, by recovering methane or preventing methane emissions, it can have a bigger impact in the near term. But generally, the standards under greenhouse gas accounting use the 100-year global warming potentials.
All right, so Amanda, there are a couple of questions in here about intensification and side stream treatment. So I'm going to read this one verbatim. In the area of nutrient removal, a number of innovative, sustainable processes have been introduced and continue to be researched, including approaches such as side stream deammonification, partial deammonification, PDNA, denitrifying phosphorus removal through anoxic phosphorus uptake, etc. What is your view of the state of the research on these technologies and their N2O emissions and the main research gaps?
Thanks. Yeah, it's a really topical one because like particularly I know in the States, but also in the UK, we have a lot of really advanced anaerobic digestion facilities that have really high strength liquors, so that the side stream processes are really are common. So I guess the good news is that there is more and more project work ongoing to try to understand them. So I know that the recent portfolio of DOE projects, I think around nutrient removal, had a number that that mention N2O emissions, as well as the the shortcut nitrogen processes, for example. So I think whenever we are transforming nitrogen, we need to be measuring nitrous oxide, and there's a lot of both academic but also increasingly utility focus on this. A great example in Switzerland is they found one facility, a Sharon plant, was emitting its emission factor. 42% of the nitrogen coming onto the side stream plant was being emitted as N2O, and we haven't talked a lot about emission factors yet, but that's a really high number. And they actually replaced that with a single stage Anamox. The challenge is there's really not that much data, and as I tried to make the point that it can be the operational conditions and the loading conditions and the efficacy of the treatment system as much as the type of process that we are talking about. So there's no golden rules. Certainly there seems to be some evidence that a single stage process, if we are producing nitrite, if we are then able to consume it immediately, this is helpful. But I think the fact that for some projects nitrous oxide sensors have actually been used as a surrogate for nitrite in order to try to get that balance right. I think we know that it is problematic. Of course, it's a balance because we're talking about carbon redirection and green energy versus abating greenhouse gas emissions. So I think the really important thing is to start with that measurement and be supporting our kind of collaborative efforts, and then only then can we really make informed decisions about our technology choices, or at least be aware of what the gaps are. So I really think we need to start talking about it more. We need to see vendors recognizing that their technologies may be part of the problem, but they could also be part of the solution if we worked on optimization. But we really have to daylight some of that data, and we need to be being proactive because we are in a climate crisis. I'll stop. Sorry.
It's all right. So I just want to acknowledge there are a number of questions that have been submitted about how to get plugged into, or how to get involved, or how to follow up on a number of the research projects that were mentioned. I'll just again give a plug to the slide that Harry put up and the climate mitigation webpage at WRF. That link will be available on the follow-up materials that we provide. That should have all of the principal investigators, and my advice is to reach out to those principal investigators directly and see how you can get plugged into those projects. All right, here's a provocative question to round us out. Water treatment plants are not large contributors compared to oil and gas and other industries. How much of an effort in the wastewater sector will, if we address our fugitive emissions, will be effective in shifting the global warming pattern? Given that we don't know exactly what our exact emissions are, how do we know that dialing in on this in the water sector is something to concentrate on? To paraphrase the question.
I mean, I think it's interesting what you see, because right now, a lot of our carbon footprints are from electricity use. And yet, as the power grid decarbonizes, then it's going to be the scope 1 and scope 2 emissions that are a lot more important. And I think that it's one where we'd like for the science, and realistically, greenhouse gas science hasn't been going on that long. And figuring out exactly what the measurements are, there's going to be some noise. And the point is to try and figure out what we need to do, how to do it better, and then go from there. But we're going to be top of the pile when we start talking about direct emissions and not necessarily how much power you use.
Amanda, any thoughts?
I always just think that I mean, trees don't take up nitrous oxide or methane, and we all need to reduce emissions. I mean, we talk about net zero, we can't net these emissions off with trees for certain, and we all see the numbers in that trajectory. You know, we aren't bringing these emissions down, so every sector and every industry matters. And then there's the whole circular economy angle. We can recover some pretty amazing products from water resource recovery facilities. And when we start to think about the carbon footprint associated with those, things like heating water in the home, like we start talking about much higher percentages of our national emissions. So I think there's lots of good reasons to be acting, but yeah.
Excellent. Well, thank you all for your time today in the audience and dialing into this this conversation. Again, we encourage you to make sure that you're registered for the follow-on webinars. I want to say thank you again to Harry, John, and Amanda for their excellent presentations and this lively discussion. You should be receiving an email with all of the resources that we talked about. We'll, as a group, kind of go through the questions that we didn't get to and do our best to try and get you some answers to some of those questions we didn't have time to get to. So once again, thank you all for your time. Harry, Michelle, if I'm leaving anything out important as we wrap up, please chime in.
No, I think we're good, I guess. So people can contact the Research Foundation for those projects as well. So, yeah.
Awesome. All right, everyone have a lovely afternoon. Thank you so much.